Hello again, welcome back. In this lesson, it's actually another lesson. We're going to go through a test prep for exponent laws. And I promise you, if you stick with me, it's going to be about 20 minutes or so, maybe longer. And I'm going through 6, 7 questions. Each question is very involved. This is not an easy test by any means. But I promise you, if you stick with me and go through each of these questions, you will be more than prepared to take the exponent laws test, regardless of what grade you are. Of course, this is mostly for grade 10, Algebra 1 and Algebra 2. But if you're grade 9, grade 8, pre-algebra, sure, you can take this as well. But this is going to be at the honor or challenge type level for you. Okay, let's start up. I have all the exponent laws that you need. There are variation that you can include in each one of these, but these are the basic ones, and you need to be able to know all of them, either depending on your school or depending on your exam. Either they're going to be given to you or you have to memorize them. Simple as that. There's nothing you can do about it. Okay. All right. Number one, simplify. We want to simplify this multiplication. This dot means multiplication. And notice that with the exponent laws, the bases, they need to be the same. If they're not the same, you can't do any of these exponent laws, okay? So bases need to be the same when you're multiplying and dividing. And in this case, the bases are not the same, but we can go ahead and make the bases the same. 2 to the 5th, we're going to leave it alone, times 8 is 2 to the 3rd, okay? And raise it to the -2. All right, now we're going to use power of power law, and that is we're going to multiply 3 and -2. That would be -6. And now multiplication of the two terms, same bases, 2 and 2 base, the same. We're going to add the exponents 2, and that would be 5 plus -6, and will be 2 to the -1. And whenever you're dealing with simplifying exponent expressions, you must leave it with the positive exponent. So you cannot leave that alone here, 2 to the -1. Then you have to change that to the positive. So that would be 1 over 2 to the 1 or 1 over 2. Okay, and I have used 1, 2. So 2 to the 3rd, I just changed 8 to 2 to the 3rd. That's the first rule that I use. I just changed this 8 to the exponent form. Then the second rule I used was the power of a power rule, which is right here. Okay, right there. That's what I used. And then I used the addition law of the exponents. So here we go. Multiplication of the terms is addition of the exponents. And then I used the law that changes the negative exponent to positive exponent. All right. So 4 things I used, and this is why this exam prep, test prep is very challenging, but it definitely will prep you for any types of test on exponent laws. Okay, let's look at the second question. Here's the second question. We have this expression. We want to simplify it. There are a few things involved here. There are a few ways to do this. It makes sense to get rid of what you can right away in terms of division. So 75 and 5. So we're going to leave the square root alone. So 75 divided by 5, that is 15. Then you're going to look at x squared and x to the 4th. So that would be in the denominator will be x squared left. And on top, you got y to the 4th. And at the bottom, you have y to the 7th. And in a denominator, you have y to the 3rd left. Okay? All right. Now, so what we can do is we change the radical to the exponential. So that would be 15 divided by x squared y to the 3rd in a denominator to the exponent of 1/2. Okay? So remember, this has 2 as a root and 1 as the overall exponent for the entire radicand. So we can do this, right? So that would be 1 over 2 in terms of the exponential. All right, now we're going to go ahead and expand. So this would be 15 to the 1/2 divided by, remember, this is the power of power. this exponent 1/2 belongs to every single one of these guys. Okay, every single one of them. All right, so we have x to the 2 times 1/2, so that would be 1. You're multiplying it. Okay, so remember, this is x squared to the 1/2. That's what we're doing. And then y to the third to the 1/2, and then you're multiplying that as well. That would be y to the 3/2. Excellent. Now, can you do anything else with this? No, you cannot. Leave it alone, and that is it. The exponents are positive. There is nothing else you can simplify. The square root of 15, we don't know what that is. To just leave it alone is an irrational number, and the exponents are all positive. All right, this is it. That's the answer to this question. Let's look at question number 3. Here's the question. We have a square root again. We have lots of stuff happening inside, moving parts. So we can couple of ways of doing this at least, if not more, but you just do it one thing at a time. Now, it does make sense to simplify if you can right away. So 32 and 4 divided by 32, we can get rid of that pretty quickly. So that would be 8. So I'm going to rewrite this as 8 times x to the negative 5 y squared times 18x squared y all over. That would be x y to the negative 3. And I got to make sure that the square root is covering everything. All right, now that we have this, we can go ahead and simplify as much as we can, and then we can deal with the multiplication and everything. From the top, what do we have? We have 8 and 18. I'm going to leave 8 times 18 alone right now. We're going to multiply that later. It's not a big deal. But x to the negative 5 times x squared. So same base, we add the exponents. That becomes x to the negative 3. Negative 5 plus 2 is negative 3. And then we have y squared times y. That is you're adding. That would be y to the third. And then divided by x, y, negative 3. There is no operation that needs to be done in the denominator. Very nice. Now that we have this, we're going to now do the math for the division. Okay? So we have the square root of 8 times 18. That's 144 on top. And now we're going to do the math. X to the negative 3, right here, I'm going to write it on the side, divided by x. That is the division. We're going to subtract the exponents. And remember, that's a 1. So you have to subtract. And be aware you're subtracting. So this is now 144 x to the negative 4. Okay, so the x's are done. Now we're going to deal with the y's. Y to the 3 divided by y to the negative 3. And that is y to the 3 negative 3. And this is very tricky one. Be careful with that. And that would be y to the 6. Okay, that's what is happening. Okay, and then once you're done that, you notice that we don't have any more denominators left because the y3 and y to negative 3, that is being divided, taken care of. So I'm going to make this a little bit smaller, the radical sign. Okay, last step, we need to simplify. Square root of 144, that's 12. And now we're going to change actually, let's do the exponential form. So now we're going to change that 144 x to the negative 4, y to the 6, all of that to the 1/2, because that's what the square root means, okay? The square root, remember, this is the r, this is a, this is n. So this is a to the exponential forms, n divided by r. Okay, it's one of the rules on top. All right, so we're going to go ahead. 144 to the 1/2, that's the square root of 144, that's 12. Then x to the negative 4 times a half, that's negative 2. This half belongs to every single one of these guys, and it's the power of power rule. That's what we're using. Okay, so next one, y to the 6 times 1/2, that's 3. Now, last step, you see this negative exponent, that's not allowed. We need to change that to positive. Let's do that. So that would be 12 on top, y to the 3 on top, divided by, we're going to use a reciprocal, and then that becomes x to the 2. We are using the law that says x to the negative n is equal to 1 over x to the n, okay? The reciprocal of the term that makes the exponent positive. All right, okay, let's look at the next question. So here it is. Notice again, number 4. This is an ugly question. It's a challenging question. I love ugly questions. Okay, so here it is. So what are we going to do? We're going to change all the bases the same as much as we can. We simplify it, and then we can do we can employ the exponent laws. So 16, be aware, 16 is equal to 2 to the 4th. Okay, you got to know that. What is 27? That's 3 to the 3. What is 9? Is 3 squared. And what is 8? Is 2 to the 3rd. Okay, so we change all of those integers into the exponential form. Now we're going to replace them with these. Okay, the exact same thing as written here. So let's rewrite this using the exponential form. 16 becomes 2 to the 4, open the bracket, to the exponent of 2a minus b, times 9 is 3 squared to the exponent of a plus 3b. Okay? And remember, this is actually the entire thing is the exponent. Looks ugly, but it's the entire thing is the exponent. All right? Now, we're going to do the same thing. 27 is 3 to the power of 3, and that is to the exponent of x plus b. Multiply that by 8 is 2 to the 3rd, and exponent of that is a minus b, which I'm just rewriting. Okay, now, power of power. We got to start doing multiplication and then figure out what's happening and divide or multiply, which means adding and subtracting the exponents. So let's go ahead and do that. So the first term, 2 to the 4, this one right here, 2 to the 4 to the 2a minus b, that is 2 to the 4 times 2a, and then 4 times negative b. So that would be 8a minus 4b. All right, distributive law, that's what we're going to do. Okay, there's no easy way out of this. Times 3, and then 2 times a, 2 times 3b. Got to do one step at a time. So 3 times 3 to the 2a plus 6b, that's the top. Then you do the same thing to the bottom. Okay, just go ahead and do that. This is what you will get. Okay, and now we're going to pair them all up. So we have 2 and 2, same base, and we can deal with that. So we're going to write one of the bases, and then we're going to divide. That means subtract. We're going to write one of the bases and subtract the exponents. So here it is. I'm going to rewrite this. So we say 8a minus 4b minus 3a minus 3b. Okay? That's for the 2 and this. We're just taking care of that. So now we're going to deal with the 3's. Okay? So multiply. And then we say 3, and now we're doing the subtraction of the exponents. So this would be same as the other one. So 2a plus 6b negative minus 3a plus 3b. Okay, so that's what we have. Okay, now we're going to go ahead and simplify. Let's deal with the 2 first. So that would be 2, and then on top I've expanded that already. So we have 5a minus b when we expand it and simplify like terms, and then times 3, and then we do the same thing here. This would be 2a plus 6b minus 3a plus minus 3b. Want to make sure that we got this right? No, yes it is, because this is the plus sign right there. Okay, so that's good. All right, now 2a negative 3a, that is negative a. 6b minus 3b, 6b minus 3b, that is plus 3b. That is the final answer to this question. This is the most simplified form. There's nothing else you can do. All right, Let's look at another question. Here it is. We're going to expand this and simplify, and that's purely exponent laws. Now, if you are in Algebra 1 or Algebra 2, you can see a shortcut that you can use, and that would be okay, and you can use that. But if you can't, you have to expand it, and that's what we're going to do just as a practice, because that is a loaded question that we can do all the source of review of exponent laws. So let's go ahead, do that, and remember, FOIL. We're going to do one term at a time, and then we're going to add and subtract, and we are looking at exponents that are fractions, okay? So here it is. We're going to start with x to the 3 half times x to the 3 half. That's the first one right here. The next round plus x to the 3 half times x to the 7 half. And then minus, so that was the second one on the first term. And then the inside x to the 7 half starts now. So negative x to the 7 half times x to the 3 half. And then negative again, because negative times a positive, because we're doing now the last one, that would be negative x to the 7 half times x to the 7 half. That's what it will be. Now, don't panic. We can simplify very, very quickly here. All right. See this middle term, x to the 3 half times x to the 7 half is the same as here. You see that? It's just that the sequence has been switched, but they're the same. Remember that 2 times 3 is equal to 3 times 2. Okay. That's one of the rules of mathematics. So this minus itself, that is 0. That's gone. There's not much left anymore. So now we're just going to go ahead and simplify. What is x to the 3 half times the x 3 half? Well, x to the, when you add the exponents. What is 3 half plus 3 half? 3 half plus 3 half, that is 6 half, right? So you're just adding the fractions. This is 6 half. We're going to simplify it more. Minus, and then x to the, what is 7 half plus 7 half? Again, right? That's 14 half. And then, of course, you simplify that. That becomes x to the 3 minus x to the 7th. Okay? So that is your final answer to this question. We expanded it, and also we simplified it. Now, if you are in Algebra 1 and at a higher level, a challenge question, you want to do this very quickly, you can actually realize that this is a difference of squares. Okay? So that would be x to the 3 half squared minus x to the 7 half squared. X to the 3 half squared minus x to the 7 half squared. And the answer will be right here. And that would be it. Okay? You can do that too. All right, let's look at another question. This one is the basic exponential equation question that involves exponent laws that you must know. Okay, so it's very loaded again. Notice that x's are in two different terms, but you got to do a couple of tricks. The first one, you take the GCF out. What is the GCF of these two terms? Well, these two terms, they have a GCF greatest common factor 8 to the x. When you open that up, what do you have to multiply 8 to the x by to get 8 to the x back? That's 1 plus. What do you have to multiply 8 to the x by to get 8 to the x plus 1? Well, that is just 8. Okay? Now be aware, right? So 8 to the x times 8, because 8 is to the exponent of 1, same basis. What are you going to do with exponents? You're going to add them. That's what you were going to get. So that's what that is. We just factor that out. Okay? So when you multiply these two, you're going to get the top two terms back, and then, of course, equals to 144. Now, what do we have? We have 8 to the x times 9 equals to 144. Well, we're solving for x. We have to divide both sides by 9. We get 8 to the x equals to 16. That's what you will get. We're solving for x now. Now notice that we really don't know what else to do. Remember, you do not know the main technique of solving exponential equation. You don't know logarithms, so you can't use that right now, all right? But in the freestyle, what you can do, you can just keep breaking it down in using the exponent law, and then see if you can manage to set each of these two sides equal to the same base. Well, we know 16 is 2 to the 4th. What is 8? Well, 8 is 2 to the 3. Well, and then all of that to the x. That means I can rewrite this as 2 to the 3x equals to 2 to the 4. Aha! Now that we have this, notice that we have the same bases, therefore, and it's an equation, therefore the exponent must be the same. So therefore in here, 3x must equal to 4, and then divide both sides by 3, and then you solve for x, which is x equal to 4/3. Now, why you're dividing by 3? Because you want to solve for x. You don't want any number in front of it. You have to divide. You have to isolate x on its own. And now you got x to the 4/3. That is the solution to this equation. And I did not use any fancy higher level math in algebra 2, which is logarithm. I did not use that, but that is the pure use of exponent law to solve this equation. All right, this was a very, very good test prep. Don't forget to take on the quiz in the description below or in the pinned comment. Make sure you go through each of these questions again, but you should be doing very well if you keep practicing. All right, until next time.